Welcome to today's seminar. This one is called SolidWorks Wizardry. To be a true wizard, one place you should go is if you go to go/x-mechanical. This is the website for Gecko Systems. That's who I work for. We do detailing and design. We set up EPDM vaults, do a lot of stuff for people at X, as well as any Google project we're willing to help. And if you go to the Gecko Systems training and tutorials page, you can see that we've got upcoming classes. I'm going to be posting July's classes pretty soon here. We've also got several tips and tricks videos already for SolidWorks. It would be a pretty bad magician if I just showed you the same tricks over and over again. A lot of these have great information, the recent developments, tips and tricks, SolidWorks magic tricks, things like that. We also have some data sheets here. There's a cheat sheet for the tips and tricks that was done. And also for the presentation that I'm about to do, we've got a slide deck that I'm about to show you now. So typically I like to steer clear of slide decks when I'm presenting, but I want to show you guys the SolidWorks settings because no one ever really covers that. And this will help boost your productivity on SolidWorks in general. I'm going to try and make this as painless as possible going through these settings. Usually what the settings are going to do is they're going to either get SolidWorks to load up faster, to solve things faster for you, or to be able to show you the graphics more quickly instead of you waiting for things to update. So on the very first page, there's some little ones like not showing the thumbnail during the Windows Explorer. But a huge one that's right in the middle is something called enabling the freeze bar. And I'll show you that as I go through this. What the freeze bar allows you to do is when you have a really complex model, a lot of times what's happening when you're getting a slowdown is SolidWorks is rebuilding that model. The freeze bar allows you to take to a point in your design that says, okay, don't rebuild past this. We're not changing this part of the design. But by the way, this will be available online, so you don't have to write everything down. If you are working with large assembly drawings, these two on the drawing display tab really matter to you as far as setting these to draft quality. If they're set to high quality, which is the default setting, when you go into lightweight mode, when you go to make a drawing of that lightweight assembly, it will load it up to show you the high quality edges. If you set those to draft quality, that allows you to use lightweight assemblies inside your drawings. And so your drawings will load up faster, especially if you're dealing with a large assembly. More stuff on the drawings. Do you really need to see the contents in the window when you're dragging it? Do you want to auto update all the drawing views? Both of these things take a lot of time. The showing stuff on drag, if it's a really big assembly, it's going to eat up your graphics card performance. And if you're doing auto update, when the drawing opens, it's going to force rebuild everything. And so you're going to have to wait for that assembly to rebuild. With these turned off, you should get right into your drawing pretty quickly. You'll see I changed the little wizard on some of these slides. Whenever you see this little wizard, I don't know if I completely agree with that setting really doing much for your performance. What they suggest here, and I got all these suggestions off of a SolidWorks blog, is to have, instead of the viewport that whoever made the file gives you, like if it's got a gray background or a gradient background, whatever, you always just use a color. So it doesn't have to draw a picture or look for a file to load up. It's just a white background all the time. All right. Also, when you're working inside of the display, a couple of things that can slow you down when you are editing an assembly and it forces transparency. If that transparency is really low or in the middle, it can take some more time for SolidWorks to generate and figure out how much you're going to see through it. Also, anti-aliasing. If you know what that is, when you have a diagonal line, remember the old like Ataris and stuff like that, it looks like a step when you're looking at a diagonal line. That is aliasing. So the anti-aliasing tries to give you a really smooth curve whenever you're looking at an edge. That's great if you're making like a picture that you want to put on a slide deck, or if you're doing a rendering or something like that. But just day-to-day work, it's slowing down your computer because it's trying to draw really smooth lines for you, and who cares if the line's got a little step to it. All right, here comes this guy. We had, like I showed you, there's a couple of tips and tricks on our website. We had somebody come in here and say that he uses opaque assemblies. So actually when he edits the colors all stay solid. That's going to boost your productivity when you're working on a part inside an assembly, because it doesn't have to force transparency. But that's a personal preference. Okay. The very first one is hugely important, verification on rebuild. What I've got in our tips and tricks, the magic tricks video, I actually go through, if you watch the last 10 minutes of this, I go in very big detail on what verification on rebuild does. Basically what it does is it does a body check every time you rebuild the part. And therefore, when you go to export it, you have a warm, fuzzy feeling that that part's going to be able to be opened in any system on the other side. If you don't have verification rebuild, you can have edges that don't match up or gaps inside of your surfaces. SolidWorks is not checking that all the time. And then you could save that part, send it out to somebody. When they go to open it, all of a sudden they get import diagnosis and stuff where there's holes in the assembly. So though it does take a little time for SolidWorks to check the part every time you rebuild, it's worth your sanity and the amount of time if you're looking for what's wrong in a part that it didn't catch the verification. They could take you hours or days of frustration, where if you have this turned on, it's going to be a couple of milliseconds every day. But I would have it turned on. The only time I turn that off is I'm dealing with like really complex surfaces. Another thing that's good for performance is when you do open an assembly, work with lightweight whenever possible. What lightweight does is it just loads the graphic information. So it's sort of like an e-drawing. I'm going to go into e-drawings a little later and show you what that's all about. But what it is just the tessellated skin of your assembly. So it just brings in the skin of your parts so you can see where they are in orientation to one another. You take measurements and things like that, but it doesn't load everything up, all the parametrics, all that. It's going to take a lot of RAM and a lot of processor time.
The next page is for assemblies. You want to make sure that the checkboxes are in front of large assembly modes and large design review. Those have to be checked on for the numbers to mean anything. Here they're set to 300 and 1000, but you can set them much lower if you'd like to. You'll see that these two types of modes help assemblies load a lot faster and build graphics a lot easier. Also at the bottom of this page, you'll see there's a lightweight envelope. Check that on. I'm going to be showing you what envelopes are in a minute here. There's a few other pages of settings here. Under the feature manager tree, I have it set to use transparent. You'll see in this seminar, I'm using it and I don't have geometry behind my feature manager tree. It just makes it a little easier for me to pick and it easier for SolidWorks to draw. And also the zoom to fit standard views.
Where was it?
I tried having that turned off.
When you put in a mate and you see those parts come together, that little video of it moving the parts together,
what it does
that takes some time for the graphics card to do. If you have that turned
off,
the part just goes right to where it's supposed to be. There's no transition.
Theoretically giving you a better video rebuild time.
Animation that goes on.
Let's see. Also transition speeds.
Also, there is a thing called indexing in SolidWorks. Make sure that's turned off when it's idle.
I just turned it on.
Yeah, can you mute your speaker, please? Okay, so there you go. That is the settings that SolidWorks thinks you should set. It gives you about 10% faster time on your SolidWorks. It depends on your system, what you're doing with it, what types of files you use, that sort of thing. But it's not a cure-all. Most of the stuff when you're dealing with lag times and things like that is loading up files or drawing the pictures of your files on the screen. This stuff will give you a better result, but it's not going to stop you from having hourglass time. It's not going to stop you from crashing. On that note, since I don't sell SolidWorks anymore, I can say that 18 is pretty crash prone. I'm hoping to go to 19 soon, and that will be better, but I've had a lot of times where I've crashed 18. Okay, so that was the end of the painful part with the settings. Hopefully you guys got something out of it. Now I'm going to go into SolidWorks, show you some cool stuff. So I'm going to start this with the R key. Why? Because I start every morning with the R key. R stands for recent documents. When you hit it, it'll show you a list of all the files you've had open recently. If you click on it, it'll open the file right away on any one of these tiles. But don't be so fast to click on it right away. It's better to click on these little expansion arrows. What that allows me to do is I can say, I do not want to load this thing resolved. If I load this file resolved, about a quarter of my presentation is going to be you watching it load up. So I'm going to switch it over to large design review, which is much better than large assembly mode. I think large assembly mode is what most people think, where you get a lightweight and it does some stuff graphically, turning it off, trying to optimize your system. But if I do large design review, we go 5, 4, 3, 2, open. So this thing takes 15 minutes if I open it full weight. It takes 5 seconds if I just hit large design review. Okay, some other hotkeys. Again, I don't want to make this all about the hotkeys, which is what a lot of these other ones do, but F for fit is a good one. You can also double click your middle mouse button. We'll do a zoom to fit. Right next to the F is a G key. Brings up this little magnifying glass. It's kind of a pain to move this around because what you do is you move your mouse and when you hit the side of the magnifying glass, it moves it over. But I'm going to talk a lot about the Control key because it's one of the most magical keys on the keyboard. If I hold my Control key and I hit the middle mouse button, I can move this thing much easier than bumping the edges. You can also zoom in here. So if you want to see a particular portion of the assembly, but you don't want to zoom all the way in, you can use this G key to just blow up a certain area on your screen. Hitting the escape key, as always, gets you out of that command. Now, the reason that I go with the large design review, first off, I don't have to wait 15, 20 minutes to see if it's the right assembly. Within seconds, I have the assembly open. If that's not it, I close it and I open the next one, large design review. When you're dealing with an assembly like this that could have dozens or hundreds of parts, it's very rare that I'm going to be working on all of those parts at once. So there's no reason to load them all up in RAM. What I typically will do is I'll have the top level assembly loaded in large design review. And then from the feature manager tree, I can start opening up whatever sub-assemblies or whatever components I need to work on that day, not working in the top level, because again, that drags things down. This part right here is fully resolved. I can tell that because of the feature manager tree. Let me talk about what large assembly mode is. So what a large assembly mode does is it does two things. The first thing it does is it loads everything lightweight. I'm going to go over to my file explorer here. I don't know if you guys knew this, but you can click on here and see what you've got open in SolidWorks. So I only have 2 windows open. You can see the stuff that's open is got a color and is in, darker letters. The rest of the stuff that has that sort of invisible part or invisible assembly thing, that is stuff that is loaded into RAM. So whenever you load up an assembly, that's what's taking so long. Just because you have 1 file open, you might have loaded 100 files. So check what's open. When you're doing large design review, the first thing it does is it sets everything to lightweight. I can do that on the fly if I just right-click the top of my assembly feature manager tree and say set to resolved, and now take a look what I got in SolidWorks. 2 files again. So when you're in large design review and you hit your feature manager tree, there are no features in these parts. All we're looking at is the graphics area. It is nice enough to bring over all the reference geometry. If you have any planes, any axes, or anything like that, those will still be in there and you can still mate to those. With the large design review in 2019, and this is another reason I want that 2019, is you're going to be able to insert parts and mate parts. Right now, all you can do is really just view them and open them. But in lightweight mode, I certainly can use any of these reference geometries, add components, mate them, whatever I need to do. The other thing that large assembly mode does is if I click this button, you'll see all the graphics went down. It hides any sketches, it hides any hidden lines, whatever takes a long time for SolidWorks to draw, it just hides all that stuff. So that's what large design, what large assembly mode is. Large assembly mode is lightweight parts. So you're just looking at the graphics and the mate references. And then on top of that, it does this large design mode that turns off all of these types of items that are going to be a long time for SolidWorks to draw when you're rotating it or zooming. All right, any questions up to this part? Okay, then let me move on here. Talk a little bit about how I designed this model. I've got a master model. And usually when I'm doing a master model, I'll put it in as an envelope into the assembly as the first thing, just so I have it handy. I don't have to go looking for it. I'm going to open this part. It is a regular part file. When you're doing an envelope, all it is a setting at the assembly level. When I make a new assembly, and I go to put in a part, there's a checkbox down here. It says envelope. If you've never noticed it, probably not. Not a lot of people use them. But when you put it in there, what an envelope is first off, it comes in transparent. It will be ignored in the mass properties. If I go to evaluate this and ask it how much it weighs, it doesn't weigh anything. Also, if I right-click in here and go into the properties, it's excluded from the bill of materials automatically. So it's a phantom part. It's no weight. It doesn't show up on your list of files, that sort of thing. It will show up in your file references. Yes, so someone asked a question, does it show up in the file references? It definitely brings in that part file. And what I did in my large assembly was I used it so that I knew when I was putting components in that I wasn't outside of the scope of the design that I was trying to make. But when I was done, I just suppressed that. So it's in my assembly so I can quickly get to it, but it's not sitting there taking up resources, rebuilding all the time. Also, the master model is great because it has all these components. Here is that freeze bar. I talked about enabling the freeze bar. This little yellow bar, if you've never seen it before, let's roll it back up to the top. Here's what it does for you. If I go to evaluate and say, how long does this part take? This part takes not too long to build, but most of the time is with this fillet. So it'll show you what's taking a long time on your features to rebuild and what your total time is going to be. If we take the freeze bar and move it down to here, it's gone to 0.1 second is how long it takes to update this now. So if you have freeze bars on a lot of your complex parts, when you do a rebuild, especially at the assembly level where everything in the assembly is rebuilding, make sure you have the freeze bar on there and you'll cut your part time down dramatically because this is what's taking a long time. The freeze bar, it's in the, so I had the question, where's that freeze bar again? In the general, the very first page, you have to enable this freeze bar. Once you've got that enabled, you'll see this yellow bar. It starts up at the top of every file, and you just need to drag it down to where you don't want it. And you'll see the things get a little padlock next to them to show me what's been frozen. I can't edit any of that. I can see it, but if I want to edit anything, I have to unfreeze it before I can edit it. So this is a pretty hefty model right here as far as file size, and it's a little time to rebuild. 5 seconds isn't that long, but the main thing that I'm worried about is the fact that this thing's pretty big. Here's a magic trick for you. If you hold Windows and press the E key, that brings up the Explorer. Let's just take a look at the size of some of these things. You know, so the Manta Master, here it is. It's about 5K. So if I'm using that on every file as like as a starting position, all my files are going to end up being gigantic. So I don't want that much information. All right, let's start with some more wizardry here. I learned this one from Brad Williamson's, and I've been using it ever since. If you select anything and you hit Control A, what's Control A do? Select all, typically. So if I pick an edge and hit Control A, it selected every edge in that part. I can go in here, start a 3D sketch, convert entities. Take some time because there's a lot of edges on the part. But there you go. Now I've got a 3D sketch of the entire design. 3D sketches can be copied to the clipboard just like any other sketch. And I'll show you this in an example a little later, but it's really easy to just grab the information, go into a part, paste that into the other part. Then you get all of the edges where their location is, but I don't have to worry about any external references. It is not going to update with changes. It's a snapshot in time of when I took that. But I don't want that because wireframe CAD really didn't make it. So I'd much rather have all the surfaces. Well, if I pick one of the surfaces and hit Control A, it selects every surface. Surface offset, I want to make a copy. There is no copy. It says offset, but there's no, if you look around here or you try and search, there is no such thing as copy. But see how this says offset? When I change this to 0, it changes to copy. So copy surface is just offset surface with a value of 0. So I can get a surface like this one. If you right click on a body, whether it's a solid body or a surface body, there's a choice to insert it into a new part. And what that'll do for me is this is what I'm going to use to help me design. I can use this at the beginning of the part when I'm designing them, and I know that my part's going to fit inside there because I can see the extents of the design that I'm doing. This is asking me, since I'm making changes on files, I've got that large design review, which is just the graphics. It's asking me, do you want me to update the graphics while you're making changes to these parts? I'm going to say no and move over. So, okay, this has an external reference. Anytime you see that little dash and a greater than symbol, looks like an arrow pointing to the right. Anytime you see that at the top of your feature manager tree, it means that this part needs some other part for its geometry. It depends on the project that you're working on. A lot of projects do not like to have any sort of external references. If you want the choice comes when I'm using this and I'm building designs, do I want to be able to drive to the designs from that top level that I had or not? If I do, I would leave it here, save it out and start using it. If I don't, there's several ways of doing it. Depends how powerful of external reference hater I am. So if I say, let's list external references, here's the references that it's getting. It's getting this surface body from the master model. If I break those, that will temporarily shut off any type of reference. So it's never going to be updating. A lot of times these parts will cause trouble because they need to update constantly. If you've got that external reference going, when you're switching windows or rebuilding, you might have to wait while the master model rebuilds. The lock choice will, the break, the lock will unlock, lock, but if you do break like I did, where you get an X, there is no unbreak. You're done. So you would think that would be fine. You still end up with sort of a ghost reference. It realizes that it's still looking for that part. It's not going to forget that. Even though it doesn't update all the time, a lot of times when you do pack and goes or you look at the references of the file, that original is going to show up because it's sort of like an appendix. It's just out there. If you want absolutely no external references, best way to do it is to save it out as a parasolid. So this is called a round trip. You'll see why. So if I say, yep, let's save a parasolid. And then when I open that parasolid, there's my model, but it's just one surface, no external references. So again, it really depends on how hardcore you are about getting rid of references. This is the best way. There's no reference. But if I need to make changes, I'm done. That thing's, you know, chiseled in stone at this point. Okay. So I've got this master part, right? And this is what I'm going to start building parts with. There's different ways that I can do it. But let's say I want to build the part that sits on here, this little sort of fake gas tank and control panel here. I want to start working on that using this master model to begin with. What I'm going to do is I'm going to delete the faces that I don't need. I hit delete face, shows me all the faces I want. I'm going to hit that one and Control A picks everything, right? So now I can just go through and pick the ones that I actually do want here. All right, that is what I'm going to design. I'm going to set it to delete them. Everything else goes away except for the piece that I want. So now I'm going to start building this. When you have a surface like this where things have been extruded through it and now the face, you know, I'm missing a bunch of what the original surface had in it. There is a tool called Untrimmed. If I try and do edge by edge, I'm not going to get a whole lot of places anywhere. But if I pick the entire face, it takes a look at it. And if it's able to extrapolate what that surface should look like, it'll put it back. So Untrimmed's a pretty crazy command. So now I've got that whole piece. It's a surface, but if I wanted to turn it into a solid, you just say thicken, pick that surface, and by default, it wants to either give it a thickness to the inside or the outside. If it's an enclosed volume, you can also just say create a solid. It'll fill that whole area in with solid. Another thing with surfaces, if I pick the edge of a hole in a surface and I hit delete, it asks me a question. Do you want to get rid of that hole or do you want to get rid of the surface? I'm just going to leave it on the hole. The hole disappeared. What? What it does is it does an untrim. It ends up, you've got a feature right here. It gives you a delete hole feature that you can suppress or unsuppress. But what it really is doing is it's doing sort of that untrim where it's taking a look at the hole, the surrounding surface, and just filling that hole up with the surrounding surface. And you see, it doesn't give you an edge or a sag or any sort of line. It's one single face when you're using that untrim command. All right, so that's how I started this part. I did have more stuff to do on it. So let me just open it up a little further along in the design process. I'm going to scroll this back here because I want to do a loft in between here. I want to have this curved edge in between these two surfaces. For the first sketch, I'm just going to start on the right plane. Do an arc. There we go. Also, I use mouse gestures a lot. I don't know if you guys have used them before. Definitely everybody talks about them and all the tips and tricks stuff. It's just a setting where I can have tools when I right click and move my mouse. I have a lot of tools available to me. If I go straight up, I can quickly get into my dimension tool. There we go. That's one sketch. Here's another trick you may not know, or you may have done by accident before. If you select an edge, you go to sketch, you open a sketch, it actually creates a plane on the end of that line for you. So what it is it's tangent to the end of that line, and it'll put it on whatever endpoint you selected closer to. If I'd selected over here, it would have put the plane over on this side. But it's good for putting things right on the end of an edge, like I've done here. There we go. So a couple of fully defined arcs. And I'm going to go in here. I'm going to do a boundary surface. It's like a loft. You just get more controls as far as tangency. So I usually go with boundary because I have more options later on if I need them. I want to go from here to here. Try that again. Here to here. You do want to pick near the same side. That's why mine was upside down. You can right click and flip connectors as well, but I'd actually hit right click and OK, so it finished it before I could set it back. And I want to use these edges. A big rookie mistake here is picking that edge and it didn't do it all the way. It needs that whole edge. It needs to go from one to the other, right? Let me clear selection. When you've got a selection box like this in SolidWorks, if you right click, there's a choice to do a selection manager. What the selection manager allows me to do is I can pick multiple items. Once I'm done with it, I hit the green check mark, it's all one line. So even though it was a composite of a bunch of different edges and arcs and things like that, it ends up giving me one. You can either right click in here, right click on the screen. If you see in one of these marks, it's recognized the tangency, and that's nice. So it picked that whole edge for me since it was all tangent. And I can just continue. There is my feature. Okay, I've got mine set to show me zebra stripes. Usually it just shows like that, and I would have no idea that I have horrible trouble coming. But when I take a look at the zebra stripes, I can see that these corners look a little jacked up, for lack of a better term. I'm going to say okay. Say, well, it looks okay if I'm not looking at those zebra stripes. But there is a problem. You can turn on zebra stripes permanently under your evaluate. You don't want to see anything like that, where the stripes are changing direction or getting all wobbly, things like that. That is a poor surface. You can really start to see how poor it is if we go to the curvature. Whenever you see things like this, where it goes green, red, that means you're going to get ripples in your surface. That's what's going on. You want to have a much better transition like this one, where it's green here, blue on one side, blue on the other. If there's blue mixed in here, it means that you've got a wobbly feature or a wobbly surface. So what can we do about it? Well, I'm going to go into my sketch tools. I'm going to start a 3D sketch. I'm going to bring up a tool you probably have never seen called face curves. Anybody here done face curves before? Knew it. Okay. Yeah. When you pick face curves and you pick a face, that's what it does. These are called UV lines. So you guys know what an XY line is on graph paper, right? The UV line is just lines that go, one direction and then the other direction, sort of like X and Y, but they're not on a flat surface. They're on a curve. And I can bump up how many curves I get to see what's happening to this thing as it's going through there. And a lot of this has to do with sort of the perception of people thinking the computer is smarter than it is when it's solving these things. You think, well, I had 100 radius arc on one side, 100 radius arc on the other side. Shouldn't it be 100 radius arc throughout the whole thing? Not really. That would be true if probably these two radiuses were closer together, but since this thing's got to stretch over this way before it starts going up here, these have really flattened out. If I go back to my curvature, when you hover over here, you can see that what the curvature on these things are. And so it's almost flat right here. And it's 129 right here. So it's gone all kinds of stuff. It's getting moshed up around that corner. I forgot to see if I hit the settings. So let me do those face curves again. Because I want to make sure that I turn off this constrain to model, at least for this example that I'm doing. Because I saw this at SolidWorks World, pretty cool trick, where I want to know what that looks like before it happens. Since I turned off the constrain to model checkbox, when that's checked on, it's going to update. When I change the thing, the 3D curves will update with whatever changes I do. But if I turn them off, they don't, which means it's not constrained to anything. I can get out of this sketch, drag it out wherever I want in the model. So I can see where that is before I even start creating all the surfaces that are around it. So you get an idea of where was the surface that I didn't like. Oh, here where it was. This is where I can make some changes to hopefully improve that. So that's one thing, pretty trippy. The other thing is just don't try and do everything at once. So the best way to do this, I can find out. Is not doing it all in one shot, but doing it piece by piece. So I know that, this radius is 100. This radius over here, also 100. So I don't get that flattening out as it goes around the corner because I've made sure that I've gone around the corner. And then I can just fill this in with the surface. I get a much better type of curvature. I don't have any of the ripples that I had down this. I don't have the black flat face like I had earlier. Okay, any questions on that? All right.
Can you use your curvature?
So his question was, can I use those face curves that I created to help drive it? Sort of, because when I do the 3D and I copy it and I take the constraints off, now it's just a sketch that I can use for, I can grab some of the lines out of that sketch if it was acceptable here and acceptable there. I can use those. No, you can't. You don't really get to modify them because they're coming off of the face at a certain thing. But what you can do is you can turn them into construction geometry and then draw whatever lines you want with them in space as you're looking at them. All right, I'm going to do another feature here. I'm going to do a slot, which is nice. Different types of slots. You can do straight slots. You can do curved slots. I'm going to do a center point one where I pick a center point, drag out a line, and give it a radius. There's my slot. When you're putting in dimensions, obviously going to line is no sort of problem because if they're parallel, it's going to give you a distance between them. If they're not, it's going to give you an angle between them. When you're doing it with arcs, though, it always goes center to center by default. There is a trick for you to do that. If you hold your shift key while you're putting in those dimensions, again, hold my shift key here to there. I'm going to do it while everybody's watching. Let me try one more time. Shift key. There we go. It's going to give me an over-defined because I got this mistake in there, but you'll see that when you hold the shift key in there, it'll give you maximum to maximum when you're going between arcs. I accidentally turned this into a driven dimension. You can turn that off here in the others. Now that's driving. All right, I want to center this thing. So I'll pick that center point. Fine. There we go. All right. I want to extrude this out, but I want to make sure that it's a really smooth extrusion that I get. When you're doing a slot, you've got 4 items. You've got 2 arcs and 2 lines. And automatically, it's going to give you a tangent line where those 2 meet, giving you 4 faces around it. I want to have it as just one single face. So what I can do with that is first I'm going to right click on this thing, say select chain. That'll give me whatever loop is there. And there's a tool called a fit spline. And what a fit spline does is you can take any combination of arcs, lines, whatever you want, say fit spline, and it'll turn them into one smooth curve. How smooth, especially when you're going with a, if your sketch has an angle or something like that, it's going to have to radius that angle to make a smooth curve. This is how tight that radius is going to be. If you're lower than your tolerance, then it's not going to really matter. So with that, now if I extrude this, you see there is no tangency edge. So it's all one surface here. Okay. I'm going to put a fillet in. There we go. Oh, something new that they added probably in the last couple of releases. You can actually try and get curvature continuity right on a fillet. You could only do it with face fillets before, but now you can do it with just an edge. And basically what it's trying to do is trying to blend perfectly from one face to another without any sort of tangency. Whether it got away with it or not, you'd have to take a look at those zebra stripes, but it looks like it did it okay. A little bit of a change there. Another new thing that they did was before, if I put in a fillet and then somebody said, no, I want you to just break the corner off at an angle, I'd have to delete that fillet, put in a chamfer. Now they give you the ability to switch from one to the other. If I edit a fillet, I can change it into a chamfer with that button right there. Same thing, you can change a chamfer into a fillet. I can also switch it to asymmetric if I want. And a little deeper, and you'll see it gives me that one smooth face because I don't have any of those tangency edges. All right, I'm going to go back to my face curves again. I liked them so much. Last time I went into a 3D sketch first. If you're going to do a lot of face curves, always go into a 3D sketch first. If you're inside of the 3D sketch, all the face curves end up inside that 3D sketch. If you don't, right now I'm not in a 3D sketch. If I pick this, I do not need that much information. And I do want this one constrained to the model. If we go down here, every face curve is going to be its own 3D sketch. So if you said I want 25 by 30, you would have 55 new 3D sketches. If you open the 3D sketch first, it drops them all into there. So you do want to keep that in mind. Also, I don't know if you guys have ever used Instant 3D. I'm going to show you some stuff on it, but you know, what it allows you to do is you can just grab a dimension, play around with it. The thing people don't like about it is when you have that on and you double click on it, sometimes the modify box comes up, sometimes it doesn't. Sometimes it's just a white box. If you see that white box, it means you have Instant 3D on. If that is really troubling to you, turn the Instant 3D off. It'll stop that. Okay. I want some holes on here. I've got a weird surface going on here, right? It goes around a corner. It's not circular. So I don't need to build any sort of plane geometry. If I'm using this thing called a hole wizard, first, it's great because it has a whole machinery handbook for all the fastener holes that you want, countersinks, counterbores, tapped holes, pipe taps, all that's in there. I'm going to do a counterbore, set the size and depth that I want. When I go to position, if I pick a 3D face, it goes perpendicularly into that face all the time. I'm just going to do one of these. I want it a little more control than that. Let's take a look at what it gives you in the feature manager tree. I've got a cross section, which is the size of the hole, and I've got this sketch, which is the locator. I can either edit the feature or just edit the sketch. If I put more points, I get more holes in this sketch. If I start deleting points, I start getting less holes. And for this, I'm going to put this point on that edge. I'm also going to constrain it. I got a mid-plane going through here. I'll just drop it right in there. So I know it's right in the middle of the thing, right in the center of the part. When I get out of here, it puts that counterbore in the correct position. Okay, I need more than one. I need a bunch of them around here. There is a pattern that I can do called a curve-driven pattern. You need to have a single item. So if you have a bunch of curves and lines and stuff like that, you can do a composite curve or something like that to add them together. Or like I showed you, that fit spline is a really good trick to getting a bunch of curves to be the same thing. But I've already got one right here with my face curves. I just have to say what I want patterned and what face is going to be normal to that. And so you can have like a spiral going around a cylinder and have patterns go up there. You can do pretty much anything with this. You just have to tell which face it's going straight into and what direction the curve goes. And then you can do things like, equal spacing, whatever you need to do, get that curve around that strange surface. Okay, so I'm going to switch gears here for a second, because now I want to fill those counterbores up with hardware. Where do you get hardware from? Anybody guess? McMaster. Do not get it from the SolidWorks toolbox. I'm not a big fan. Unless everybody's on the same library, it doesn't really work well. So I usually just go and get my files from McMaster. They've got so much hardware in here. All I got to do is just dial up what size I want. And then it shows me all the different types of materials that I can get, or different left-hand versions of that type of socket head screw. If I click on an item and go to product detail, here is a data sheet. It's got all the information as far as what it's made of, the classification for it, even a nice little 2D drawing for it. I want to save this information. So I'll right-click and print this out as a PDF. So there's my data sheet. I can also get the model. Another reason I like McMaster is because they're SolidWorks centric. If I hit save, it's going to download, there it goes, an SLD PRT that I can just click on and open right in SolidWorks. Okay, I'm not done with this. Do not save this to the vault yet. The number one thing I was talking about, graphics is usually the problem when SolidWorks is hanging up or taking a long time. One bolt inside an assembly is not going to shut down the whole works. But if I have 100 of these bolts and they're all mated in place, and then I switch to wireframe and it's got to draw that helicoil for 100 different things, my computer has just frozen. And now I can't rotate it. It's just locked up. So please do not save these into our vault. Just suppress the helix. There we go. You can delete it, but this thing's got so much equations and stuff going into it. Usually if you delete it, you end up having to troubleshoot it. I don't want to do that. I just want to use this thing. So I'll hit save. And there we go. I don't want that one. I want this one. I don't need the large assembly mode because I actually want to see these edges that I'm dealing with. Okay. Let's talk about getting this part in there. It's really easy. If I just click from the feature manager tree over to this one, it drops it in there. But look at all those. It's got planes and sketches and all sorts of stuff. So not only do you need to suppress the helix, it's also good to hide any sketches or planes that they've shown. There's a couple of ways of doing that. At the very top of your feature manager tree, if you've never noticed this little funnel, click there, type in sketch. There's all the sketches in that part. It's tricky. Another way to do it, Ctrl T flattens out your feature manager tree. So by default, it's like that, where all of the features that have underlying geometry, the underlying geometry is shown embedded in that feature. But if I hit that Ctrl T, it's just a flat representation of everything that's in the part. So I can see pretty clearly the dark sketches are the ones that are shown. So I want to hide all those. Now when I go into my assembly, I don't have all those sketches hanging out. Again, not too bad on one bolt, but if you put 100 bolts in there, now I have 100 sketches that keep popping up and have to be redrawn every time I rotate the part. Okay, if I needed to put this part in, you need to put it in with mates, right? So I can hold my Control key and select two cylindrical faces. Gives me a concentric. Hold my Control key again to pick two faces at once. When I release the Control key, I can choose to put in that mate. So that's pretty slow. I told you the Control key is magical, right? Hold the Control key, drag, drop, makes copies right from the feature manager tree. Or right from the graphics. So if you hold the Control key and drag anything, it'll always want to make a copy. The reason I wanted to do this is I wanted to show you that there's other ways for me to put this in. There's something called a smart mate. So if I'm clicking and dragging this edge or this face, nothing's happening. But if I hold the Alt key while I do it, you see when I get one cylinder over the other, I get those two little tuna cans. It wants to put in a concentric. This one's a little harder because I've already got the thing selected. So sometimes it's tough to do that whole Alt key, at least when you're talking about doing them one at a time. So they came up with a better thing. For any part that's a nut, washer, or a bolt or something like that, it's a hole that's going up to a face, or it's going into a hole and it's going up to a face. So they gave you a twofer. If I hold my Alt key and I pick a circular edge and I drag it over another circular edge, you wait for that little peg and hole. And what that does for me is that puts in concentric and a coincident at the same time. Okay, that's a lot of Control key holding. I don't want to do that anymore. I want to make it simpler than that. Okay, if you have a part open and an assembly open and you know the edge that you want, there's no Alt key necessary. I just click, drag, bang. Okay, still too slow for me. I'm going to come up with something, and we're going to go through this in a little bit more detail later on because it's a pretty powerful tool, but I'm going to use it really simple to get you used to it. It's called a mate reference. You find it in the reference geometry, just like planes and axes. But if I pick an edge and say, okay, that's a mating edge, that is basically like me picking the edge and holding the Alt key, picking the edge from the other screen. Once you've got that mate reference in there, it's now going to be looking for that. So I don't need to make sure I get the edge or anything like that. I can just drag it from the feature manager tree right in there. It knows what edge I'm talking about. But wait, there's more. Remember the magic trick? You hold the Windows key, press E, brings up your Explorer. All right, 908A64. That's this one. you can do it right from Windows Explorer, and it puts mates on there. Because it's got that mate reference, it doesn't care. It already knows where it's supposed to be going. So that's how the toolbox does it. If you ever use SolidWorks toolbox, it's always just popping parts right in there. It's because every one of those has a mate reference. And you don't even need to open the File Explorer. You actually have a File Explorer right inside of SolidWorks. Oh. No. Go back in here. I'm looking for the user. There it is. All right. I got too much stuff open. Hey. Huh. All right, so I missed it, but I can just finish it over here. So you can also go right from your system right here. And if it's got an external reference in it, it's going to snap into position. Oh, okay. Um, sorry about that. There we go. Okay, part's back, which is good because I actually, there we go. So, like promised, I can go from that File Explorer on the right side and just drag and drop. Again, if you've got an Explorer, whether it's its own Explorer window or the one that's built into SolidWorks, if it's got that made reference, it's going to lock into place. I'm not going to put all these in one at a time. It's a much better way to put things in like this. If you've got a pattern that the holes are in, leverage that pattern. So if I say, okay, I'd like to do a pattern-driven component pattern. What you do is you say, I want one of these, and you can pick more than one. If you have a stack, if it's got washers and nuts and all that, you can pick all of the stack. And then just pick one of the features that it's supposed to go in, and it'll do all of them. So anytime you see one of those counterbores, give me a hole. The reason that I prefer doing it this way is that if I go into this part, and I edit this pattern, right now it's got 8. If I add a couple more, go back into the assembly, did not rebuild for me. Yeah, it did. There's 10 of them. Okay. I go in. Now there's 10 nuts, bolts. So if I take them out, if I put them in, it'll readjust and put the right amount in. Where if you put them in individually and you change the number, now you got to go take out, put in however many you just changed that number for. This one's a little more automatic. Okay, any questions for me on this one? In the audience or out there in TV land? Okay. I'm going to go back into the options for a second here. What I want to do is I want to bring in an imported part. I've got this step file. Before I open it up, I go into my options. Because again, SolidWorks has done some stuff with their default options, give people fits. Enable 3D Interconnect is on by default. It's something that they came up with a couple years ago. What it allows you to do is you can bring in an imported file without really importing it all the way. Let me show you what I'm talking about. So I'm going to turn on that option. And then open this. Actually, that's probably going to take a long time. Unfortunately, there's no escape on this. So I'm going to have to let it finish or kill SolidWorks here, which I think I might do. Because I know it's going to take about 5 minutes, and I just don't want to tap dance that long. Sorry about that, because I do already have them saved out as interconnect and saved out without interconnect. And I'll show you the difference. All right. Another thing, as far as SolidWorks taking a long time to open or working well, is what kind of add-ins you have. It showed me a list of the add-ins it was loading up. If you go to your tools add-ins, you want to make sure that most of these are off. Only the things that you work. The only thing that I have on for mine is my data manager I have on because I'm always in the vault. But everything else I turn on as needed. It makes my machine run faster. Also, I don't end up taking out professional licenses or premium licenses by accident. If you have the add-in for simulation turned on, you're going to end up pulling one of those simulation licenses. Okay. Let me go to find, here's one with interconnect. So let's just pretend that that 5 minutes that I just spent talking about add-ins, I was actually still waiting for this thing to open up. What interconnect does is it gives me a file with an external reference right here. See that? If I right click and say list external references, it's looking for that step file. The idea behind interconnect is if you get a vendor part that's a step file or an IGES or whatever they're sending you, a Parasolid, you can bring it in open with interconnect, put that original step file into your vault, and then every time you open up the file, it'll open up that step file. If the vendor sends you a new step file, you can just swap it out, and this part will open up with that new step file. But that's not really how most people operate, and certainly not how I usually do it. I would rather just see this as bodies. So when you're doing your open and you have it set to step, you want to make sure that the 3D interconnect is turned off on your import options. And also, here's another important one. Import multiple bodies as parts. If that's turned off, the multi-body part will come in as a single file with multi-bodies. If it's turned on, it's going to create an assembly with sub-assemblies and components. This thing has about 150 components in it. So if I were to open it up, now I have 150 components to manage, and I don't care about that. We buy this one thing from them. I'm not going to be buying pieces for it. Also, wherever you open up that step file, when it has to create those 100 files, they end up wherever you opened it up from. So if the step file was on your desktop, now you have 100 files on your desktop. So kind of make sure where you're going to save it to, as well as whether or not you want all those parts in there. All right, when you bring it in without Interconnect, this is what it looks like, a bunch of imported bodies. So if you just see a single feature there, you've probably got Interconnect on. It's going to come to bite you because it's got an external reference. When you go to check it in, it's going to want you to check in. The other thing, if you're working with the data manager, it's going to give you nothing but a headache. So try and set that no Interconnect. And let's take a look at this import. So it's got a lot of information in it. If I section this thing, you know, they've got ball bearings and stuff in there and every connector that goes in it, all the nuts and bolts that hold it together. I don't need that much information. So I want to just pick the outside bodies. Here's a trick. If you hit function F5, it brings up what's called your selection filter. Sometimes people will turn this on by mistake. If you hit E or V, you know, it'll just be filtering edges or vertexes. You can tell when it's on because your cursor turns to this little funnel. If you want it to stop doing that, function F6 turns everything off and on. So that's a toggle. F5 actually brings the toolbar up. F6 toggles what your selections are, whether they're on or off. So I say, okay, I just want the bodies on this one. So I'll start picking the bodies that I want. Definitely want the outside shells. Some of this information in here would be helpful. There we go. That's all I need. I don't want to have to pick that over and over again, though. Anytime you've got a selection set that you really like, you can right-click and save that selection. Turn off my selection filter here. And you'll see I've got saved selections right here. So what I want to do is I want to delete bodies. I don't need that many bodies. It's nice because it gives you the choice of whether you want to keep or delete, because I picked the things that I wanted to keep. I didn't pick the things I wanted to delete. So I'm going to switch to keep bodies and then pick that selection set, fills everything in for me. And now I just have the basics of what I need. I showed you mate references earlier. And it was a very simple mate reference. I didn't even name it. I just picked one edge, save, done. If you're talking about putting in nuts and bolts, that's fine. But if you're putting in something a little bit more complicated where you've got to clock it and things like that, that's why the mate references allows up to 3 different mates. So what I'm going to do is I'm going to say, okay, this face, coincident, this face, concentric, and then to locate it, I'll pick this one as concentric. The trick here is I want to name it. So I'll call it motor mount. And now I've got a mate reference in there. Got a couple because I worked on this part before, but now I've got a mate reference in there that keeps that information for me. I'm just going to go ahead and save that. All right. Go back into here. I wanted to show you some other information that you can get. When you select on an item, you'll see this thing called Breadcrumbs pops up. When they first came out with it, I completely ignored it because it was up in the upper left-hand corner. I wasn't even looking there. So they gave us another thing. If you hit your D key, it comes to wherever your cursor is. What's nice about this is I can see what subassembly it is. I can pick the part or the face. You can break it down. You can even see what mates are on there. You can edit the mates while you're doing it. So you get a lot of information without having to go over to the feature manager tree, which is typically where I get all this information. Here's another one. I want to pick that green part, but I keep picking the part underneath it. It's because it's a transparent part. Transparent parts, you always pick through. If you hold your shift key, you can pick the transparent part itself. There we go. And then I can open the assembly right from there if I want to. So it's nice. I can not only find out what subassembly it is, but just say, open that subassembly. And then I'm working on that file. Also, when you select a file, it always gives you an open, which will open the part file itself. It also gives you this open drawing, which is new. It always gives you that, whether there's a drawing or not. If you click it and it sends you to a browser, it means it couldn't find the drawing. Where it's looking is it's looking in the same folder the part's from, and it's looking for something with the same name. Okay, so here I've got a drawing, and I want somebody to take a look at this, tell me if I'm on the right track or if I need to make any changes. There's a program that loads with SolidWorks called eDrawings. If you've loaded EPDM or you've loaded SolidWorks, you have eDrawings on your machine already. If you didn't know it, you can use it as a viewer. You don't actually have to, send it out to people who don't have SolidWorks. You yourself can open stuff in SolidWorks, like this drawing. So you can see not only does it open eDrawing, but you can also open any SolidWorks file. And the information is stored in there. I talked a little bit about the graphic information that's saved in every part and how that bumps up the file size and things like that. Even in this is, if I show you this, maybe you can understand it a little bit more. If I pick on this drawing view and click here, it has the 3D model in here. So this is the graphic information that gets loaded when you're doing like a large design review or something like that. And that's embedded into every part. So the more complex parts will get larger because they've got to save all this graphic information in the background. If I go back to the home, it'll put files in there. You can do markups, and this is why I like this tool. The thing is that I can put in a note for somebody, or I can highlight an area where I'd like them to do something, like this entire area here does not have any information. So I can do some markups with this. And once I'm done, I can save the markup to a file. Why would I want to do that? So in that place, I was playing the engineer that's like, hey, here's the changes that I'd like to make. I open up an eDrawing. Yep, that's the right part. No, you need a motor mount here, and you need to fix up the title block doesn't have any information. When I go back into that drawing in SolidWorks, back in that options page, I got a couple options here that I didn't really talk much about. On the feature manager tree, all these different folders. I turned on two that are usually off by default. One is the design binder. The other one is this eDrawing markup. So that's why I can see it here on this one. If you have the eDrawing markup on, what you can do is you can insert that markup. So if I just type in eDrawing here in my search, I can say insert a markup, and it brings over whatever markups the guy put on there for me. So you can actually see it in your SolidWorks drawing as you're working on it, so you don't forget anything that's on your red lines. If you're finished with it, you can either hide it or delete it. Okay. So I showed you from the assembly, I can pick on a part. I can open either the file or the drawing. And when I'm in a drawing, I can also pick on a drawing view. Open up the solid. There it is. What I need is I need this here. Let's talk about, grabbing information from one place to another. I'm going to open up a sketch here. And I'll pick all the geometry that I need on this shape. So I need those 5 mounts and this collar here. I hit convert. That's the shape that I need in 2D space. If I box select around that, one of my choices here is to make a block out of it. What a block does for me is it turns it into one single unit. I can even copy that to the clipboard, which I just did. So I picked on the block that I made, I hit Ctrl C. And for this part, I'm just going to put a little base on here. Then I'll pick this face, Control V, there's my block. So the block moves as a unit, where usually with a sketch geometry, if you click and drag on sketch geometry, if it's underdefined, it gets just dragged all over the place because it doesn't know where it's supposed to be. But when you save sketch geometry as a block, it moves as a single unit. Even if I pick on the block itself, I go into edit the sketch, pick on the block, I can do other stuff with this. I can scale this thing, I can change the orientation on it. So different stuff you can do with the block. What I want to do is I want to make sure it's right in the middle there. Blocks are nice for me, but they're not nice for anybody who comes after me and wants to make changes to this part because that's just locked into that shape. You can get rid of a block, explode it. It just turns back into its geometry. If you have a sketch that's underdefined with a single button, you can say fully define this sketch. Probably not the way I would have dimensioned it, but now at least somebody can get down to the parametrics and change the dimensions on this. So I'm going to do a couple of extrusions here. By default, SolidWorks wants to extrude the entire sketch. I can change that and say, no, let's just extrude that section right there, that much. I wasn't finished with the sketch. It's okay. Select on it again, hit extrude again. I'm extruding with the same geometry. I just need to tell it what I want to extrude, which is these mounting bosses. There we go. Okay. This was not my end goal. All I'm doing here is I'm creating the features that I need in that other part. Why am I doing this part? What I want to do is I want to create what's called a library feature. We go in our design library. Design library has all kinds of things for us. Remember when I was showing you blocks? Actually, you can do blocks from drawings. That's how blocks originated. So they're pretty easy to do. The same thing like I did at the part level, where you just grab the information, make it into a block, and save it. But also in the design library, we have these features. What I want to do is I want to select the features I want. So I want those to be my feature that I'm going to put on there. I just click and drag them over into my design library. I have to give it a name, like mount. And you'll see it's set to this SLD LFP, SolidWorks library file. This little thing, it's not an error. It's just letting me know, hey, if you've got a cut or you've got something that's extruded on top of it, it needs that basic feature as well. Is it okay if I make a simplified version? Say yes. And it brings out just what I want. It's very impossible to see, but there's two little L's on top of these extrusions, letting me know that those are library features. Also, at the top of my feature manager tree, I no longer have a little part icon. I have a little set of books letting me know that this is a library feature. All right, close and done. But I still don't have the parts on here. All right, here comes the magic. What operation is that? Oh, I'm in a sketch. Okay, so can't do it while I'm in a sketch, but I can do it now. So I just want to click and drag it. Any flat face will do. Because the flat face is where I extruded the stuff from. That's what it's going to remember. It also takes a look. I had a relation. I had this thing set to be concentric around the circular plate that I did. If I have a matching edge in this part, there it is. So now I've got a motor mount here, and I got this motor mount. I can click and drag on any parts. I can put motors on everything. So it's a nice tool to be able to, copy items very quickly. If you take a look at this part, I've already got one set of mate references that match the mate references that I put on the motor. You can put more than one in a file if you have a lot of things that you're putting into an item. I can say, let's do a mate reference. You just might got to make sure that you get the selections correct as far as which one was the first circle I picked. Pretty sure that's right. And you also need to name it. If you want them to match up, they need to have matching names. Spelling does count. This is one of those times that SolidWorks actually allows you to name something the same name twice inside a file. So see, it's got motor mount 1, motor mount 2. I'll save that. Bring this in here. Now, here's my motor. So okay. I don't know why it closed out on me. But this should be the one. Oh, it's minimized. There it is. Okay. So I've got the motor mount here. I've got two motor mounts in here. All I need to do is get close to that and it snaps it in place. If I select on an item and say, show me the views, you'll see that it put all three mates in there for me right when I dropped it in there. So this is a huge time saver if you've got a lot of things to mount and they always mount up the same way. You just put those mate references on there. And then again, if you click and get it near a similarly named mate reference, it snaps right into position. All right. Any questions on what I've shown you here? All right. Let's take a look at some more things here. Now, when I designed this all using the same master model, I have the same XYZ for all of my information, which is really helpful when it comes time to putting the assembly together. If I just switch for assemblies, I got one here called a wing. I go to drop it in. If I just put it any old place, it's just going to drop in any old place. But if you hit the green check mark, it automatically hits the part origin on the assembly origin. Since all of these are using the same reference file that has the same origin, I just drop it in. This part fixed in space in the right location. So I'm done. SolidWorks does not have to solve any mates for me. It's just that's where the wing is. All right. Typically, this type of vehicle would want two wings. So I'm going to put in another one that's mirrored. Pick the plane, and then I'm going to pick this entire subassembly. When I go to the next page, it shows me a preview, which doesn't look so great. It looks very much upside down. SolidWorks can have you flip it about the X, flip it about the Y, or flip it about the X or Y. It doesn't matter. I only got 4 choices and none of them fit. The reason is I need a left-handed part here. The left side wing is not going to work on the right side of this vehicle. So what I need to do is if you select an item and you hit this little bell, it automatically will create a left-hand or right-hand part for you. That's going to be another file with an external reference. You want to be aware of that, of how it's doing this. When you are creating the new file, actually you have choices. If you're somebody, one of those projects that absolutely abhors external references, you can click on this. What it'll do is it'll create another configuration in your original part that's got that mirror in there. So you can have the left configuration, the right configuration, one part, doesn't have to have external references. If I say create a new file from this, it's going to have an external reference to the original file. So different ways you can do it. It's going to create its own file. I can choose whether I want to put on a prefix or a suffix. You still have to use legal characters, so that's just after that. Also, as far as your mirrored body, what do you want to bring in? Do you want everything? Do you want all the surfaces, or do you just want the solids? It gives you options on what you want to do. Are you going to bring in the mate references? We'll put it all. I'm just going to bring in the solid bodies. I say okay. And in the background, it's creating the mirror part for both of these components and the mirror assembly as well. And it puts it right into place. If I look at this part here, it's got a hinge. I want to have a matching hinge on the part where it mates up. And I showed you if you want to steal 2D information, a block is great. You can start a sketch, you can grab the information, put it in a block, take it over to another part and use it there. You can also do it with a 3D sketch if you want 3D information. So I can say, okay, let's put in a 3D sketch. There's the axis of that hinge. Let's copy that. And then copy that 3D sketch to my clipboard. Open the part that I need the thing on, paste. There's my 3D sketch. That's where the hinge needs to go. Again, because they're all designed in the same orientation, because I'm using that master model, it's very nice that I can just grab information from one and put it to the other. An enhancement that they came up with not too long ago in SolidWorks was the ability to do a sweep without having to do always a sketch profile. If I switch it to a circular profile, I just need to put a diameter in here. And then it just sweeps that diameter down that line. This is really great for making cables and pipes and things like that, but also works on this one as well. I'm going to make sure that I don't merge the result at this point because I want to keep this separate for now. I want to show you another tool. There's a tool called Indent, and there's a couple of different ways you can use it. In this case, I'm going to create a cut. I want to make sure that this part here doesn't interfere with that part there. When I say cut, what it does is it cuts the shape of that one body out of the other one. If I hide this, there's that sweep taken out of the part that I want. If I go back into it, I can even put in an offset of how far I want it. So by default, it'll do it right up to the body, but you can have it go a little away from the body to give yourself some clearance as well. So that's the indent tool. There is a trick if you want to create two bodies with that, one body out of two. You can just select them, right click, will get you right to the combine tool. Do the Boolean operations here. and I'll just mirror those bodies over to the other side. Okay, I do need to cut the thing out, but I'm doing this kind of fast because I only got about 25 more minutes here. When you do a mirror, it locks in position in the mirror position. If you don't want it to be mirrored anymore, or in that position all the time, you can just dissolve the mirror feature. The components will stay behind, but now they're not in position. The position was determined. They were always, a mirror. So if I took that original one and I moved its position, the mirror would move too. But here I want them to be independent. I also wanted to show you some other types of mates that are available. So SolidWorks has a lot of these mechanical mates. I don't know if you've taken a look at those, but they've put a lot more in there over the years. They've always had the gear mate in there, the cam mate. Those were simple. The gear mate takes a rotational and a rotational. You just do a ratio between them. When this one goes around 4 times, this one goes around once. Rack and pinion or screw is where you're doing rotational and it turns into linear motion, where the rack and pinion goes side to side along the pinion, and the screw, as you screw it in, goes deeper or out of the hole that it's in. What I want to do is a hinge. So they all have different selection sets. For the hinge, I need to pick 2 concentrics. You can use the axes or the cylinders, and then you also want to put the ends where they meet up. If there is any sort of clearance in there, this will not work for you. But now you can see I got that motion. Another type of mate, you can do limit mates in the standard mate, either angular or linear. In the advanced mates, I can do limit mates, which allow me to take these 2 faces and I can put in a high and a low. So it can go between 0 and 120. Currently it's at 30. That gives me the ability to move it, but I can't go past here and I can't go past there. I talked about the Instant 3D. If you have an angle or a distance in Instant 3D, you can control those using this. What's nice about that is when you're doing this Instant 3D, if you have what's called flexible parts, like if you had tubes that were lofted in between those two, those would solve as it's moving up and down. So it looks almost like real time. It's kind of choppy, so not exactly real time, but you can get an idea of whether you're going to have problems with stuff and getting pinched or crimped when you're moving it. Okay. Hitting down the home stretch here. I showed you an indent earlier where we were taking the part and we were using the part as a cutting tool, or the body as a cutting tool. I've got another indent here. Let's take a look at this. The other way that you can do an indent is rather than cutting the shape out, where if I use these, it would just put 2 holes in there that were shaped like whatever, wherever they interface with the original. But I'm going to do the indent again and say, okay, this is the body that I would like indented. And then tool body regions, it's weird. It depends on which side you pick. So if I pick the face on the top, the indent's going to come out of the part. If I pick the faces on the bottom, it's going to go in. So I'll show you. If I pick here, see what it does? Or if I picked up here, so it matters where you select. So you want to pick on the side that you want indented. And it's the same thickness as the rest of the part. It's just pushing that shape into that part and retaining the thickness. I can also, if I need to have, some sort of clearance, I can type that in there. Now that's 2 millimeters away from every space on that body. So it's a nice command where you've got, I know what this shape is. I just want to punch it in there. That's what you can do. It does leave the surfaces or the features behind, the bodies behind, but gives me a nice feature there. It's the same thickness as the rest of the part. When you start getting into this, this is why we got some files that are pretty darn big. When you're looking at this, here's my top level assembly. I've got a part file in that top level assembly that takes up more RAM than the assembly itself. This is where you have to start thinking about what exactly is in a SolidWorks file. So there's the header, there's the feature manager tree information, there's the parametrics, all the numbers that you typed in there. That's actually a very small amount of data. Most of the data in a part is your graphics. I've talked about it a bunch of times. It gives us the ability to do the large design review where it's just loading up the graphics. In e-drawings, I can see a part. I don't have to convert it into something. I can just open it up because the files already have that 3D geometry in there. If the 3D geometry is extra complex, you get a ridiculous file size like this. So let's take a look at that part, and hopefully the part will play nice with me because it is so large. A lot of times when I'm playing around the feature manager tree, I get a lot of hourglass time on a part like this. But it opened up pretty nice because I've got everything frozen. I don't want this rebuilding, or I would still be working on it today. Okay. Unfreeze this. And let's see if that sends it into a tizzy. I guess while I'm waiting for that, I can tell you why this thing is 50 megabytes for a part that's not all that big. I got another part that's flat, looks just like this. It's only like 4. There's a couple of big items here. One is the Deform feature that I used here. What Deform does, it's similar to the Indent. I've got this shape, if I show it, that I drew. I wanted this flat piece to look like this revolve. So that's what the Deform does for me. Is if I edit the feature, I can either use a primitive, like I can say, do a sphere, do a cube, do an ellipse, whatever. It'll push that shape into my solid. Or you can say selected body, and I pick to whatever the shape of that revolve is, that's what I want pushed into that shape. But just doing that has made this much, much more complex. But it's not the worst of the worst. Let me go in here and talk a little bit about different ways of putting images onto a surface. The easiest way is to use a decal. If I pick on a surface, go over here, add a decal. There we go, there's our little wizard. Pick the face I want the wizard on. And there he is. I can play around with the location of this, with the size. Drag it into somewhere where I want it. Sometimes you have to zoom in if you get it too small. But there we go. That's about the right size of the wizard. Now I can see, you can't really see on the graphics here, but on my screen it comes out a lot more where I can see the edges of the white because it's actually a big square picture. It's not just a wizard. There's a whole big amount of white around him. You can mask that. If you happen to have a file like this, that's the negative of that guy. Now it's perfectly wizard shaped. It's not gonna, I'm not gonna see the edge of the decal here. It's not gonna start bleeding into my other artwork here. So that's how you can put on a decal. Decals will only show up in SolidWorks. They'll show up in e-drawings, they'll show up in a drawing, but if you ship it out to somebody with another system, they don't get your decals. So if it's something like the artwork that I've got going here, that I want to make sure if I send somebody a step file, they realize they can't, I don't want them drilling holes where I painted or whatever. These will come across with the file, but there's two different ways that I did it. One's called a wrap and one's called a split line. A split line is much easier. You've probably used them before. What a split line allows you to do is you take a sketch, you pick a face, and it just projects that sketch 90 degrees from your sketch plane onto that face. So when you're doing this, your circles are going to turn into ellipses, things like that. They get stretched over the face because they're at a different angle. They're not trying to conform to the shape. They're just getting like shooting a picture onto the shape. The other one here is what's called a wrap. And a wrap is a little different because what a wrap does is it actually takes that shape and lays it down over whatever contours are underneath it. So it's actually more like putting a sticker on something instead of shining a light on it. And so you're not going to get, you know, your circles will stay circles or close to it. The thing is, if I go into my evaluate performance, wow, that wrap takes a lot of energy. It has to figure out what the shape is, what the thing is, and then lay it over it. It's got to do a lot of thinking before the wrap happens. That's why I'm afraid to even roll past this, because this wrap, oh, going onto this surface. Also, if you take a look at the sketch behind it, let's see if I can open it again just on its own. But that kind of thing, that's why that part is so gigantic. It's because it's got a really complex surface that I use with that Deform, and it's got a really complex sketch that it's wrapping. So it's taking all those squares and it's pushing them onto that surface for me, which takes an extra lot of computing power. But here's the thing, the file size is mostly just the picture. It's not the solving that's making big file size. Here's how I can show you that that's a thing. Spelling counts after delete. There we go. I want to delete that whole body. Now, I usually wouldn't do this if I'm just working on it by myself. I don't care. I mean, it does take a long time to bring it over in RAM, but it's not taking any time to resolve because I got that freeze bar enabled. This is if I want to ship it over to somebody. I want to email this, but my email does not let me put in a 50 meg file. So I'll do this one as okay, so we had the front guard that was 51 megabytes. Where's that brand new one I did? This one. That can't be right. It hasn't finished saving. Once it does finish saving, though, I think I've already got one in that folder. Here we go. So there it is, 653 kilobytes. So an overwhelming amount of that is the graphics to it. So I can just delete that, save it, send it to somebody in email. In the email, say, hey, just delete that delete body at the end of it, and boom, the part comes to life on their thing without me having to ship them a 50 megabyte file. So just some more wizardry. There are a couple more things I want to talk about before I get out of here. Let's go back to this drawing. All right, remember I had those markups? Where's all the information in here? The loom part, where's my part number? Where's my date? All that information. Okay, what's going on here? Well, I haven't filled out all my metadata like I should have. If you have a part and you go up here, you can go into your file properties and you can start filling out what the file name is, what the part number is, when it was drawn, all the date, all that stuff. But I don't like doing that. It takes a lot of typing and I'm not really sure what exactly I need, all that sort of stuff. So I'm going to use this custom property tab. What the custom property tab allows me to do is it's just a link to all my metadata. So I give it a name. I say who it's drawn by. I'll have Monty check it for me. I apply that. And now my metadata has all that information that I typed in there. Also, if the information is already in there, it'll be listed there already. It'll be filled in. So I go back to the drawing. And some of my information filled out, the part number, the description, that's coming from the part file. Other information I have here is actually coming from the drawing file. It's okay. You can do custom properties on the drawing level as well. And there we go. That information gets filled in. So how am I doing all this? How did I even get that thing started? There's a tool inside SolidWorks. Go to SolidWorks Tools. It's called a property tab builder. You can start this from scratch. It's pretty easy. You just see these different group boxes. You just drop them in and you can start dropping in text boxes, whether you want to have a list, number, you can do check boxes. You can even have it when you put on a check, it shows you different, like if you say this is a purchase part, it can show you different things like, okay, what's the vendor? You know, it's kind of choose your own adventure. So you can set these up. Here's what people will see. But here is the actual metadata name. So you can say you see this, but this is what it'll write to. You also have control. Is it writing to all of them or just the configuration specifics? I'll even open this one up. If you guys are in Loon, that's what you're looking at, is the one that I created for Loon. It's actually in the Loon library in their vault, but here's all the information, you know, and you can see what it's filled out for. You need one for assemblies, one for drawings, one for parts. Set up whatever metadata is important in those, and then you can do like I did. Just go to that tab, start typing information in, hit save. When you check it into the vault, I already know it has all the metadata because I filled it out. All right, one more tool, and then I'll get out of here. I know I only have about 5 more minutes, but I like this one. It's called the treehouse. There's different things you can do with the treehouse. You can build your own assembly up. You can start thinking, okay, it's going to have a sub-assembly that has a few parts. Oh, and there's a part that's here, and I want this one to have a drawing. So you can set up an entire hierarchy of what the assembly does. When I click on Save to SolidWorks, it'll save the SolidWorks assembly with the sub-assembly with 2 parts. The parts will have drawings Everything will have the references already done for me. And I just need to start building the geometry. So you can build it from scratch, or if you have an existing assembly and you're not really sure how it's set up, drag and drop your assembly into the treehouse, and it will give you a visual representation of the hierarchy of your assembly. Also, you will be able to see, what configuration things are in. If they have drawings, there'll be a flyout for a drawing there. So you can get an idea of the top level of your assembly as well. Okay, that is SolidWorks Wizardry. Hope you guys enjoyed it. I will be posting this on the Go X Mechanical next month. Our presentation is going to be from Hawk Ridge Systems. They're kind of come in and show us Flowworks, which is a CFD to do electronic cooling, aerodynamics, those kinds of things. So thanks a lot, and I will see you guys later.